All right, up till now, we have done multiplying polynomials, just for the sake of it. But they can actually come in handy when you're trying to solve more complicated equations. So here we're just going to take a couple of quick equations to show you how you can use what you've learned to solve some equations. So what if you have s minus 4 times s plus 1 is equal to s squared plus 5? Before knowing how to do any of this multiplication, you wouldn't even know how to attack this. How do you solve for s, right? You want to get s by itself, but you have all this stuff wrapped up. You can't do it unless you multiply and collect all of the like terms together. So here, you just go ahead and you do your FOIL, right? Here's the first term. S times s is s squared. The outside terms, s times 1 is s. The inside term is negative 4s. And the last term, negative 4 times 1 is negative 4. On the right-hand side, you have s squared plus 5. So you want to collect like terms. So you notice that you have an s squared here and an s squared here. So you want to go ahead and combine those guys. So the way you would do it is you'd subtract s squared from this side, move it over here, but you remember that as soon as you do that, basically s squared goes away. Because we have s squared on the left and s squared on the right. So if I try to subtract s squared from both sides, they're just going to disappear from both sides. So it's gone, right? It's gone. So that you can just kind of disregard that. The only thing I have left now is s minus 4s minus 4 is equal to 5, right? Now on the left-hand side, I see I have an s minus 4s. So these are like terms, s and s. So what is s minus 4s? It's going to be negative 3s because you subtract them. 4 minus 1 gives you 3. Negative comes from the bigger number. Minus 4 is equal to 5. Now, we want to eventually solve for s, so let's move the 4 over here by adding 4. We're doing the opposite. Negative 3s, we add 4 here, that gets rid of it. On the right-hand side, we add the 4. So we add 4 to both sides, so we get negative 3s is equal to 9. And now, the grand finale is we get s by itself by dividing both sides by negative 3, because there's a negative here. So it's 9 over negative 3. On the left, it cancels and gives us 1. On the right, s is equal, 9 divided by negative 3 is negative 3. So the answer here is negative 3. So this would be hopeless to solve unless you knew how to multiply these. You wouldn't know how to isolate it. Students would just kind of go bonkers. But if you expand it out, collect the like terms together, get s all by itself, then you're actually able to isolate it and solve. All right, for our last problem, we're going to learn how to solve an equation that looks like this. X plus 4 times x minus 4 equals x minus 2, x plus 6. Again, if you didn't know how to multiply polynomials, this would kind of look hopeless. You wouldn't know where to begin. But now you know when you have these here, you have to multiply them. So let's multiply the left. First terms, x times x gives you x squared. Outside terms, x times negative 4 is negative 4x. Inside terms, positive 4x. Last terms, negative 4 times positive 4 is negative 16. On the right-hand side of the equal sign, we have to do the same thing. First terms, x times x is x squared. Outside terms, x times 6 is 6x. Inside terms, negative 2 times x is negative 2x. And last terms, negative 2 times 6 is negative 12. So we do FOIL on both sides of the equal sign because that's how we have the multiplication set up. All right. Now we look and we try to collect terms, and we notice right away that we have an x squared on the left and we have an x squared on the right. So because of that, they're basically going to cancel out. If I try to subtract x squared from both sides, they're going to both disappear, right? And we also notice that I have on the left-hand side negative 4x and positive 4x. These are like terms that I can add together, but since negative 4 plus 4 is 0, both of these basically disappear as well. So on the left-hand side of the equal sign, all I really have that's left is negative 16. On the right-hand side, I have 6x minus 2x minus 12. But then I notice right away that I can simplify these terms on the right-hand side because they both involve x. So I have negative 16 is equal. 6 minus 2 is 4x minus 12. So now we're finally getting here. So since x is already here, let's leave it there. Let's take the 12 and move it to the other side by adding 12. So we have negative 16 plus 12 is equal to 4x. We basically add 12 to both sides and it disappears from the right-hand side. Now when we add this, what's negative 16 plus 12? I think you'd agree it's negative 4. Because basically we subtract them and get 4, and the negative sign comes from the bigger number. And on the right-hand side we have 4x. Okay, so let's actually just do this. Actually, I don't need any of these equal signs like this, actually, because I have the equal sign here. All right, and then to get x by itself, we divide by 4. So we'll have negative 4 divided by 4 is equal to x. So we divide by 4, it goes away there. And then finally, negative 4 divided by 4 is negative 1 is equal to x. So it doesn't matter when you solve an equation what side of the equal sign x is on. Here we have negative 1 is equal to x, so you can rewrite that if you're happy to do that and say x is equal to negative 1. Whatever side of the equal sign x is on, whatever's easier for you, just get it by itself. And if you leave it like that, that's fine. If you want to rewrite it and say x is equal to negative 1, that's fine too. But either way, that's how you do the problem. So we are done with this section. This was multiplying polynomials. And we started out basic. We started out with really simple multiplications that just involved exponents. And then we got bigger and bigger and finally got to the point where we're multiplying binomial times binomial. And I tried to tell you, okay, you learn about the FOIL method. And we did the FOIL method. We practiced it. But I'm trying to drill it in that the FOIL method is nothing more than just distributing all these terms inside the parentheses. And, you know, that's a lot of students get confused in algebra where all the rules come from. It's a great example of really, it's no new rule. It's just an easy way for you to remember it that all of the books have you remember. And it's easily extensible to if you get larger multiplication problems, you know what to do, which is another advantage of really understanding what's going on. So make sure you can solve these problems and work extra problems in your book. Check your work. Go watch this video again. Work all of these. Multiplying polynomials is so important. You'll be using it constantly. And then once you master this, follow me out to the next section where we're going to begin to learn how to divide polynomials, which you'll find out is not that big of a deal once we get some good examples and some good practice.